Okay, students, now we'll start with chapter number 2. This is the third lecture. Chapter 2 is motion along straight line. Okay, we will start with section 2.1, which is in page 34. Displacement, time, and average velocity. We need to start with this shape. You need to be careful with it. If we have 2 points, point A and point B, starting point and end point, okay? We have the R displacement, which is the straight line between the 2 points, which is the shortest distance. The shortest distance and which has an arrow or a direction, this is a vector, which is a displacement. But if we have this distance, there is no direction for this distance. It is not a straight line. We can go in also another distance. We have many distances, but we have just one displacement from A to B, which is the straight line. And we need to denote by it by a sample, for example, R, with an arrow over it to say this is a vector. Now we will deal with this experiment, this virtual experiment. This is me, and I am on a straight line, which is the X direction, for example. And I can take the scale as I like. So I take these steps as 10 meters, 20, 30, 40 in meters. And this is also 10, 20, 30. This is in positive and this is in negative. This is not theta, this is negative. In negative direction. This means that this direction is forward and this direction is backward. Easy? Now, if I do two actions, the first, I was at the origin. I need to have or to define a reference point. The reference point, which is the starting point, I can take it as the 0. So I will take the X initial, or the X1 is 0, and the time at this stage is 0. It is the starting point. The first action, I move forward from 0 to 30 meters. When I measure the distance or the position, or I measure also my place, it is 30 meters. When I look at my watch and I see the time, it is 1 minute. 1 minute means 60 seconds. We can convert it easily. So the time at T, at the second point, is 1 minute or 60 seconds. Then I move backward to 20 meters backward from the initial reference point. It is a minus 20, minus 10, minus 20, minus 30. This is minus 20. And when I measure the place or the position here, it was negative 20. And when I measure the time, it was 3 minutes starting from the initial point. So I was at T equal 0, T equal 1 minute, T equal 3 minutes. Okay. We need now to calculate something known as the change in place, or the rate of change, okay, in place. In the first action, I see that X initial, which is equal to X1, I choose to name the position by x because we are on x axis. We can use the y axis, but we can use here x axis. X initial, which is x1, I choose it to be 0. And x final, which is x2, is 30 in meters. This is the unit. And it is positive 30. The t initial, which is t1, is 0 second. In SI units, we need to use the seconds and meters. We don't need to use the minutes. And t final, which is t2, is 60 seconds, which is 1 minute. Now, it is important to know what is the rate of change in my place. What is my speed or velocity? Speed and velocity are different things. We will talk about them. The rate of change is the average velocity or average speed. To tell you something, when we talk about the vectors or the displacement, it is the velocity. When we talk the change in distance, it is the speed. The velocity is vector, but the speed is not. Okay, the average velocity or the average speed in our direction here is the change in place over the change in time or on time, which is delta x over delta t. This symbol is delta, which is the triangle, is delta, means the change in x, change in time, which is x final minus x initial over t final minus t initial. What is x final? It is x2, which is 30. What is x initial? It is x1. What is t final? It is t2. What is t initial? It is t1 in our situation here. Okay, now we need to start put our numerical values in our formula. V average is equal to x2, it is 30. x1 is 0, it is the initial place, over 60, which is t2, over t1 or t initial. The units are meters over seconds. Now 30 meters minus 0 meters, it is 30 meters. We can add and subtract the same quantity, meters from meters and second from second. It is 30 over 60 meters over second, which is a half meter over second. Look at this now. We have steps. We start to understand the physical or the concepts in physics. We draw our graph or scheme. We understand all of our problem. We know the initial point, the second point, the final point, and draw it and understand the problem well. We recognize the variables or the parameters, which are x, the position, t, the time, and we also know and find the numerical values for them, which are given. Now we have the next step. We need to know the law, the physical law, which is the formula, which is V average, which is delta x over delta t, the change in place or position over the change on time. The next step, we need to substitute the numerical values in its place in our formula. The final step is to find the result with the units, and we need to know where is the direction of our motion. It is positive here, that means it is in the positive x-axis or to the right, okay, or forward. Now let us look at the second action. I was at 30 meters, then I go to minus 20. My first time is 1 minute, then my final time is 3 minutes. Okay, I understand my second part of my problem. I need to know the variables and the parameters, the numerical values of them. Now in this stage, I have a new x initial and x final. X initial in this stage is x2, which is 30. X final, it is x3, which is minus 20 meters, because I go backward and I pass from my original place and go to the negative direction. This is negative direction, as we told you before. Okay, what about the time? The time at initial point now in this stage is 60 seconds. Then the time at the final point, it is 3 minutes, which is 3 multiplied by 60 seconds for each minute. Each minute is 60, which is 180 seconds. Now, what is my average velocity in x direction? Now, I asked you before about the rate of change in my place, and I didn't ask you about the direction. But after we solve the first part, we know that the change of rate is the average velocity, and the direction is important in our solution now, which is in x direction, positive or negative. So I ask you now, what is the average velocity in x direction? So average velocity, it is the change in place, which is delta x, over the change in time, which is x final minus x initial over t final minus t initial for this stage, okay, which is x3 minus x2, not like the first one, over t3 minus t2. Now I know the numerical values. x3 is minus 20, minus 20, minus 30, which is the initial place, over 180 minus 60. All of this is in meters over seconds. You can put meter, second, but it is, if you know that the units of the velocity is meters over seconds, you can put it aside. So negative 20 minus 30, it is negative 50. 180 minus 60 is 120. This will be equal to minus 0.417, I rounded it, meters per second. The units of the derived quantity, which is the velocity, is meters over seconds. What about the minus sign and the positive sign in the first part? The negative and the positive signs mean that the direction of the motion is to right or to the right or to the left, or positive x negative x direction, or forward or backward, or positive y or negative y if we are moving vertically, and so on. I hope you understand this. It is easy to be understood. We will solve more examples and you will need to solve more examples. Thank you.